Good evening. நம்ம என்ன பார்த்துட்டு இருக்கோம் கேட் क्वेश्चन சால்வ் பண்ணிட்டு இருக்கோம் கேட் 2022. இது வரைக்கும் நம்ம ரெஃப்ரிஜரேஷன் அண்ட் ஏர் கண்டிஷனிங், தியரி ஆஃப் மெஷின் அண்ட் ஃப்ளூயிட் மெக்கானிக்ஸ் क्वेश्चन சால்வ் பண்ணியிருக்கோம். இப்போ நம்ம தெர்மோடைனமிக்ஸ் அண்ட் தெர்மல் இன்ஜினியரிங் क्वेश्चंस சால்வ் பண்ணலாம். ஸோ ஃபர்ஸ்ட் क्वेश्चन பார்த்தீங்கன்னா an engine running in an auto cycle, so thermal engineering, where V is 250 cm3. So velocity of volume of displacement கொடுத்துருக்காங்க. Clearance volume is 35.7 cm3, whose P1 is 100 kilopascal, T1 is 300 Kelvin, Q of the engine is 800 kilojoule per kilogram, CV is 0.718 kilojoule per kilogram Kelvin, CP by CV alpha வந்து 1.4 கொடுத்துருக்காங்க. Find its maximum pressure கேட்குறாங்க. ஸோ இதுக்கு வந்து பார்த்தீங்கன்னா ஃபர்ஸ்ட் அவங்க மென்ஷன் பண்ணிட்டாங்க இட் இஸ் விச் இஸ் கிவன் இஸ் அன் auto cycle மென்ஷன் பண்ணிட்டாங்க. ஸோ ஃபார் தட் we have to draw the auto cycle PV diagram. So this is pressure, this is volume. So auto cycle is also called as constant volume, so constant heat addition, constant heat rejection. So this one is a 1 to 2 compression, suction, compression, heat addition, expansion, like that it will happen. Here it is heat is added, that value is given here as 800 kilojoule per kilogram. So what they are asking is maximum pressure. So we can see the pressure at the point of 2 and the pressure at the point of 1 and pressure at the point of 3. Here we can identify the maximum pressure is occurs at that of 0.3. So what is the value of P3 is asked. So for going that we should have to know the relationship between that of PVT. So for a PV is equal to M, or T is an ideal gas equation. So we can consider this as a P1 by P2 is equal to V2 by V1 is equal to T1 by T2. So consider as a P1 by P2 is a king, so it is given as alpha minus 1 divided by alpha, where V2 by V1 we can consider this, P2 by P1, so P2 by P1 and V1 by V2, V1 by V2 and T2 by T1. So it is alpha minus 1, this is just alpha minus 1, here it will values will be 1. So what they had given, we can consider P1 T1 and QCV and V and VC. So with the help of V and VC we can calculate the compression ratio. So the compression ratio is nothing, so the compression ratio, this is we can call it as a swift or displacement volume, this we can call it as a clearance volume. So compression ratio is clearance volume plus swift volume divided by clearance volume. Here the swift volume is 250 cm3, clearance volume is 35.7, again the clearance volume is 35.7. When substituting this and we going for using calculations, so 250 plus 35.7 divided by 35.7, we can conclude it as an 8, right, 8.00. So R value is 8.00. Here the compression ratio R is in the graph point, we can say it as an V1 by V2. So volume at the point of 1 divided by volume at the point of 2 gives the compression ratio. So we can say it as a V1 by V2, which is in the format of alpha minus of 1, which is equal to 8. So we can say it as an 8 power alpha minus of 1. Also V1 by V2 can also be written as in temperature format of T2 by T1. So since T2 by T1 is equal to V1 by V2 alpha minus of 1, since V1 by V2 is equal to 8, we can write here as an 8 power alpha minus of 1 T2 into T1. So the T1 value in the question it is given as 300. So alpha value is 1.4. So I am calculating 8 power 1.4 minus 1 will be 0.4 into 300. We can say it is a 689.21. 600 and so for the verification, see the value is 689.2190, right? So we have identified the T2 value first. So here from these values, the T1 and T2, P1 and P2 is we have to going to find. So for this we have to use the same relation here. So what is the relation? So for that of radical purpose we are going for new pages. We can say it as a P2 by P1 whole power alpha minus 1 divided by alpha is equal to V1 by V2 alpha minus of 1. So on cancelling, this alpha minus 1 will cancel. So V1 by V2 already we had found as an 8. So P2 by P1 whole power 1 by alpha. From this we can get the value of P2 as 1839. So from this we have identified P2 is equal to 1810, T2 is equal to 689 Kelvin. So what we have to go into next is we have to find that of P3. For that of P3 we should have to know what is the value of T3. For that Q is equal to mCV del T. Here the mass is given nothing, so we have considers 1. So CV is given as 0.718. So del T, here the value is Q value is written as 800. For that of del T, which it means the Q is a heat addition. The heat is added in the process of 2 to 3. So del T value will be T2 minus T3 or T3 minus T2. So on simplifying this, 0.718 we can write here. T3 is we need to identify. So T2 is we have identified as a 689. It is 800. On simplifying this, we can get the final answer of 800 divided by 0.718. 1114.20. Again the minus it comes here, it will become plus 689. So you can answer 1803. So T3 value is 1803.2, right? So this is the T3 value. So again we are going for ideal gas equation PV is equal to mRT, where P is directly proportional to temperature. So P1 by P2 is equal to T1 by T2, or P2 by P3 is equal to T2 by T3. Here we have to find the P3, so we are going for this equation. So what is the value of P2? We identified as 1839. So 1839 divided by P3, we need to find what is the value of T2. T2 is 689. What is the value of T3? We have identified as 1803. On cross multiplying this, P3 is equal to 1839 into 1803. Whole sum is divided by 689. We can get the answer as 4812. So we are getting 4812, but the exact answer is 4809, which is nearby the same. So the P3, the highest pressure value for the given engine is 4812. Okay. So this is the method how the sum should be approached and solved. Thank you. Good evening to all. So today we are discussing the gate questions. In previous videos we had completed refrigeration, air conditioning, fluid mechanics and theory of machines of gate 2022. This session we will discuss the thermodynamics and thermal engineering. So the given point is it's a given as a Rankine cycle. For that our question, I had shortened the question for our easy understanding purposes. So WT1 is a 400, WT2 is 850 kilojoule per kilogram, and the pump work is 50 kilojoule per kilogram. Cycle efficiency is given as 32%. Find the Q rejected. WT1 means the turbine with a high pressure. WT2 means the turbine with a low pressure. So before going that, we should have to understand one basic thing, that is turbine is an work producing device, right? Whereas pump is an work absorbing. And then the formula for efficiency is heat supplied minus heat rejected divided by heat supplied minus of heat rejected divided by heat supplied. So here the efficiency of cycle is given as 32% and the heat rejected is asking. So using this formula, when we have the value of Q of S Q of S, we can find Q of R. So for that, the efficiency of cycle, we can say that of work done divided by heat supply, right? So here the work done is given as 3 work dones were given. First one is 400, second one is 850, both are turbines, and the third one is 15, which is a pump. As first one is a 400 comes from turbine, we are using the positive value. The second one is also turbine, we are using the positive. And the final one is pump, so we are putting minus 15, and the Q supplied is not given, we have to identify. Where the efficiency value is given as 0.32, we have to substitute on solving 400 plus, so going for calci, plus 850 minus 15, we can get 1235 of Q of S. On simplifying this, we can get the answer of 1235 divided by 0.32, 3859, 38, so answer is a 3859.37 is the heat supplied, right? So here the asking is what is the value of heat rejected. So substituting these Q supplied values in this equation of initial equation, so efficiency is equal to heat supplied is 3859, heat rejected we need to identify, and the heat supplied is 3859, and efficiency value is given as 0.32. On simplifying this, 3859 minus of Q of R. On simplifying this, let's simplify and find the answer. 3859 into 0.32 is 1235. 38 minus of QR. So minus of QR, here it is in positive value. When it comes under here, it will become 90. So minus, so 1235 minus 3859, we can get the answer of minus of 2624. In both the side it is minus, so it is cancelled. So Q rejected is 2624 kilojoule per kilogram is the right answer for this question. Okay, thank you. Well, good afternoon. Today we are discussing the GATE 2022 questions. So now we are dealing with the TD and TE, thermal engineering thermodynamics question. The first question is one dimensional heat conduction, thickness is 0.1, T of higher is 80, T of lower is not given, but the H is given as 4.5 kilowatt per meter square. So and K is 15 watt per meter, it's not H, it's given as Q. And then what is they are asking is what is the del S, which it means del S generation they are asking. So for that we should have to find the values of T2. So it is a given is QL is given, we are directly going for Q formula, Ka del T by del X. It is in the form of K by A. which it means watt per meter square. So Q by A we can write it as a 4.5, which it means Q by A is equal to K into del T by del X. Here the K value of thermoconductivity is given as 15, del T is given as T1 minus T2, we can write. Here the del X thickness is 0.1. So 4.5 into 0.1 divided by 15. So what is the T1 value? T1 value is given as 18 degrees Celsius while converting into Kelvin. So 80 plus 273, we can it is 353 minus of T2. On simplifying this, we can get T2 as 4.5 into 0.1 divided by 15. This minus of T2 is equal to 0.03 minus of 353. So we had one side, we had to calculate the answer is coming nearby values, so we have to check 0.1 divided by 15, we are getting 0.03. It is in the minus 1 when it comes to there. Here we are getting the values of nearly 350 something, so we have to once again go for verification. So here instead of 4.5 we are getting 4500 divided by 15 into 0.1, because in the question it is given as 4.5 kilowatt per meter square. So instead of K we are using a 000, so on point calculation we will get 4500 into 0.1, which is equal to 353 minus of T2. So T2 is equal to 4500 into 0.1 divided by 15. Here it is 30 plus 353, and simplifying we can get the answer of 30. So we will get answer as T2 as 323 Kelvin. So successfully we had found out the T1 and T2. What the mistake we had it is, instead of 4.5 kilowatt we just substituted as a 4.5, so the mistake we had it. So second one we are going for entropy generation. So entropy generation is equal to entropy at inlet minus entropy at the outlet. So the entropy formula is dQ by T. So here entropy of Q value is 4500, hence it is 4500 divided by T in. T input value is T1. So T1 value in the question is given as 353 minus of the same 4500 divided by T output is 323 we have identified. So in understanding I can write the formulas delta S of T of input minus delta S of T of output. Okay. So on simplifying this, 4500 divided by 353 minus of 4500 divided by 323, we can get the answer of 1.184. On differentiate, which means on finding the difference between these values, we can get to 1.184. So the value of delta S, difference between them, is 1.184. So the entropy generation is of this given diagram is 1.184 open square Kelvin. Okay, thank you.